Welcome to the Mischief. I'm Vallen, and this is Immersive Engineering for Minecraft 1.10. Alright, so previously we covered the coke oven and a whole bunch of other basics that, they kind of help out a little bit. You know, getting around, not everything was used, but now we're going to get into a little bit more stuff here, like the crude blast furnace. We're starting off with this, and we're going to grab a couple other items, and it's made in the same exact way as the coke oven. You're just going to want to put this down here, a few blocks in a 3x3 cube. Simply put, there's no hollow spot in the middle, no need to pour lava in or anything like that. It's just basic stuff here. And once it's done, then you hit it with your, well, you don't hit it, because if you did hit it, you'd left click. But instead, you're going to right click, and you'll create this little hole in there. Now, if I right click on it, I'll get a little user interface, and it's a crude blast furnace, so it will not have any automation options whatsoever. Your stuff will not pour out like the coke oven does here with the creosote oil buckets and the blocks of coal coke and stuff coming out. No. Instead, you have to use the old method, which you can put in iron ingots or blocks of iron. I recommend blocks of iron with blocks of coal coke so that you can get your best efficiency out of this. Now, that block of coal coke is going to burn for a very long time. You see this? It is working. It's just that slow. This is the whole idea between a crude blast furnace. You can upgrade this to a regular blast furnace. But you will need steel to do so, and that's what this produces. Over time, your iron will be turned into steel. You'll also have a byproduct of slag. Oh, there we go. Our first percentage is there. You will have a byproduct of slag, which is good for creating, like I said over there before, concrete. You can get more concrete with slag than you can with other methods. But your steel production is going to be needed for a very large percentage of stuff. Nothing you see out here, though. I might have like a single block out here that requires steel, but this is all non-steel items. So while your steel is being created, you can therefore go out and start making up all the rest of this stuff, which is what we're going to get into next. So before we get into these, I'm going to get into a little bit of power production. Now, in power production, there is quite a bit of interesting stuff going on. You can make now this one here is a creative energy cell in a way. It's called a capacitor. Now, you have your low voltage, medium voltage, and high voltage. High voltage requires steel. So this is what I'm going to focus on, pre-steel stuff, because it can take a very long time for you to get enough steel for you to actually advance in this mod. It's a bit slow, but it also encourages you to have some time so that you can make some prettier stuff around your base. Now, with this, we have multiple ways of connecting them. In your traditional Minecraft mods, you'll have a lot of like cables that you put around. Instead, with this, you've got wires, connectors, relays, switches, transformers, all sorts of what sounds kind of scary at first. It's not that bad. Trust me on this. It's pretty good, actually. So, what we have here, we're going to start with low voltage. Now, with this, a low voltage capacitor, think of it as a battery. So, the recipe for that is a bunch of iron ingots, copper, lead, copper, treated wood planks, redstone, very basic stuff. This is going to store, I think it's around 10,000 RF in it. Now, it might, the type of energy that's stored in there might have a different name depending on the progress of the mod, but currently it's 10,000 RF. Now, it also works with EU, last I knew, and EU to RF is like a 4-to-1. So, with this, you also have a connector, which is what's needed to transmit the power in or out. But before I do any of that, I should show you that with your hammer, you can make inputs, outputs, or just nothing at all. Right now, I see blue on top, output, nothing, input. So, this is how these function. Now, of course, you can do the same thing with, this is a creative cell, but I mean, you only get this if you're in creative mode. But this is the idea. You can have multiple connectors on here. In order to have power come out of this or go into this, you're going to need a connector. Now, there is another item called a relay, which looks very similar. If I put this on the side here, you can see and you can put these anywhere in the world. It's not going to really stop you from doing so. But a relay is a totally different item. It is not meant for putting power into or out of something. It just allows power or multiple cables to connect together. In this case, like this. So if I take some cables, I could only connect one-to-one with connectors, whereas a relay can have multiples. So with that in mind, we will also need some coils. I have here low voltage wire coil, or LV wire coil, which is the lowest entry-level tier that there is. Now the recipe for it is a bunch of copper wires around a stick. You're probably thinking, well, how do I make copper wires? This is where you can either use shears or your wire cutters on a copper plate. So that's how you make this stuff, and that's where your wire cutters have a first use. Your second use is in detaching other things. For instance, you'll notice here I have a breaker switch that has a wire going up to here. Now sometimes you can get away with this kind of clipping issue where it goes through it and it doesn't, and it's not obstructed. Other times it will say it's obstructed. Now there are also advantages to this. Allow me to demonstrate with this wire relay. Now if I put this here and I put a block between these two and I try connecting, I just right click this coil and I right click I right click the coil on the relay and then I right click over here. It says it's obstructed. If I destroy that and I try it again, it then says it's good to go. Watch this. Oh, you'd think, uh-oh, that's trouble. No, it's not. That's the beauty of this mod, is that these wires are meant to go through blocks once you've connected them up. So that is advantage number one. The other thing is, it's like, oh shoot, you know what? I have, let's say this relay is connected to other relays over here, and I don't want to disconnect both of these wires and this wire if I break that. So how do I just disconnect it from this one? Well, if you have a wire cutter, you could just use a pick or something and break this one, or you just right click with your wire cutter and it instantly cuts the wires that are connected to the item that you just clicked on, which I find quite useful indeed, especially when you're dealing with lots of wires and you don't want to mess up too badly. So I have other items here that are being described. So right now I've got a battery. I have a connector which allows power to go in or out. I currently have this set to input mode. I have some extra relays on here that I was just demonstrating with. We don't even need those. That's just going to make it confusing. So I have it connected to a breaker switch right now. A breaker switch will interrupt current. So if I have power running through this coil cable right now, and I have a breaker switch connected to it, it connects in just the same way. For instance, let me use my wire cutters here. Boom, I just cut all the wires from it. So now I need to shift right click onto that, shift right click onto that, and therefore I connect the wires. And each time that you use this, I'm in creative, so you're not seeing the numbers go down. Every time that you connect one wire to another location, that will use up one of your wire coils. So making a lot of these is going to be very beneficial. They have a range of about 16 blocks, and they can transmit 256 from a connector, or run a total of 2048 RF from one wire with multiple relays, which I will go over that in a minute. That's kind of confusing, but just know that for now you could run about 256 RF on one of these coils. But there's also going to be a little bit of loss for distance. Now, as I was saying, a breaker switch. This here, let's say there's power running through it. I can then turn this on and you'll see that stuff will start flowing. What is the current transformer? Current transformer allows you to monitor things. So if I right click, it says average energy transferred over the last 20 ticks, 0 flux per tick. So that means any energy running from here through to there is nothing. So we're going to want to make sure that this is going out. Everything is connected up properly. We've got our switch going. I turn it on, and therefore you'll see on the top left there that it is currently powering it up. Hit the switch, and it breaks the connection here. Now, you'd think, well, why don't I just use levers and stuff? Well, that's not immersive engineering. Immersive engineering does use levers for many things, but not for power in this case. So, if I were to run that, it is currently running. Now, if I right-click on here, it says 255 flux per tick. That's great. It says 256. Well, that's because with certain levels of coil of cabling, the wire I should say, you'll have some losses. depending on the distance traveled. So the higher the voltage, the less loss you'll have. So that's the advantage, one of them at least, in switching to a higher voltage. Now in this case, I have a medium voltage capacitor, which will run 1024 on one connector and 8192 on one coil. So let's start this one up, hit that, and you should start seeing it's going in. And of course, this is a capacitor which runs a lot more. I believe it stores 40,000. And if I click on here, it says 1022 flux per tick, which is much more than the 256. Plus, it's, you're losing, what, like 2 flux per tick? And it's running 4 times as much. This one's losing, at a similar rate, it was losing 1. So you'd have to multiply that by 4. So you'd lose around 4 versus losing 2. So already this is a little bit more efficient, but it's made with different stuff. You'll notice that the cables, if you look really closely, these ones the coils are a little bit lighter colored. Now, of course, the capacitor is made a little differently as well. It uses electrum, which is made from electrum grit, which is made from gold and silver together, as I demonstrated in the previous video. Now, this is basically just going to allow you to store and transfer more energy. So the higher the voltage, the better off you'll be. But it's sometimes a lot easier just to use the lower voltage. And sometimes there are items that will only use lower voltage, like certain lamps, for instance, that I have up here. Those ones only use low voltage, and there are ways of converting one to another. Now in this case, this is a creative capacitor. It can just have multiple hookups on it without an issue. If you're using a MV capacitor, you're going to want to use an MV wire connector. Same thing with LV. You're going to want LV connectors and wires. Because if I try and use an LV wire coil, let me disconnect this one here. If I use LV wire coil on an MV system, it's going to say you cannot attach this here. It's just incompatible. So you can't really have them work like that without some kind of step down. And there are those in this. But before we get too far into that, let's explain a little bit more with what I was talking about with getting a lot onto one unit. So right here, let me clean out some of that spot there. I have low voltage. So this is all a whole bunch of low voltage capacitors that are all set up to input right now. So they're going to accept items. And you'll see I've got a relay, which means that it will transport the full 1000, 2048 on the wire, because the relays don't have that limitation that connectors do. So this is a medium voltage connector, which will transport much more. Medium voltage will transfer 1024. So in this case, 1024 to a transformer, that's right, a transformer. This is just an MV and a LV wire connector, electrum coil block, and some iron ingots, which the electrum coil block is a bunch of MV wire coils around iron. And you can connect those together. It's actually a 2 tall block. I just did this so that it was a little bit more easier to connect up. But you then connect the medium to the medium, the low voltage onto the low voltage, which in this case, I don't know that I have that hooked up. So let me grab my low voltage wire, grab this here, to that, this, to that, and there we go. And you'll see there's no power because I currently have a breaker switch hooked up. So once I flick this lever, you'll see a lot of stuff happening here, and it is currently powering it up. Let's disconnect that. Grab one of these current transformers, and we'll see about using this. Actually, let me set it up this way. Now, I'm going to cut this. There we go. Cut that, and LV wire coil from here to here, here to there, there to there. So now when I flick this lever, I can then see how much is traveling through it. 1000 flux per tick. What the heck? How is that happening? Well, it's happening because it is currently using a medium voltage instead of the 256, and it is separating into all these ones, so it's transporting a lot of energy. Now if I go over here to this one, This is all just low voltage. So I've got low voltage capacitors, and you'll notice that this is low voltage capacitors, but because I've got that step down here with the transformer, it allows me to switch between voltages. Now in this case, I've got all low voltage, and I've got my relay, which means that this is not limited. All the cables together can transmit that, was it 2048? I can never remember. Yeah, 2048. And I have one connector here, which is limited to 256. So if I throw this lever, it's going to say that it's not going to transmit enough. And to save yourself some time and effort, I recommend making yourself an engineer's voltmeter, which is a compass, couple of sticks, and a copper ingot. Very basic. So when you hold it, you point it at something, it will tell you how much energy is in there, how much is going on, 0 out of 256 per tick, and so on. Now, looking at the relay, nothing really is happening there, but let me here switch this lever, and it should be going. Yeah, things are currently moving, but you'll notice that nothing is actually properly in place. Let me put another current transformer down here. So in this case, I currently have it going from this creative capacitor cell to a low voltage connector. Then it's going over to a whole bunch of others. And you'd figure, well, there's a lot of stuff going on over here, and they're all just about done. So let me switch this quick, click on here, 182, 243, and then it starts dropping off because it's actually, they're filling up. But it never got above like 200 and something. The reason for that is because it's limited by this connector. This connector is 256. Now, as much as the wire itself can transmit 248, it's limited by 256 for the connector. So if I were to put a medium voltage connector on here, run it through a transformer like I did over here, then it will allow me to transmit a lot more on these cables. So that's something to consider. And low voltage and medium voltage are both craftable before you get into the steel level. As is the transformer, which is just iron and electrum. Not too bad. And to show, for example, I currently have the same exact setup over here. I've got all those low voltage capacitors here, which are storing about 100 KRF. Oh, I guess I was wrong on that one. For the size that they can store. That's 1 million RF. Okay, well, here you go. 100,000 and 1 million. So that's been changed a little bit since 1.7 to 110 as well. And these here, I set up with outputs on the bottom. Now, you could have a lot of connectors coming off of one unit going into one relay. In this case, allow me to demonstrate by saying I could do this and then take some low voltage cable to that and adding on to this. So it's got two different connections of 256 coming out for a total a little over 500. So that is one way of getting multiples out in using the LV wire connectors if you don't have the MV ones yet. Now in this case, I currently have this hooked up here to a MV capacitor, which is not very happy. There we go. I just remembered I shouldn't be clicking the switch with coils because it tries to connect it. So once I do that, then it's got a lot of power coming through. Now remember, these are all LV cables, so it's got them coming through with a max of 2048 per tick. So that's pretty darn good. All right, so in this case, I switched it around so that I've got this current transformer here so we can check it out. Now I've got it all hooked up. It's all ready to go. This isn't full yet, so when I throw the lever, you can see it's starting to fill up. You can see we've got over 1,000 flux coming in, which makes about the right amount of sense here for what we can do. So there you go. Some of the basics on how to understand the how these work. Now, I've just been talking about batteries, connections, and switches, perhaps even stepping them up and stepping them down. But I haven't talked about how to make power yet. There are multiple ways of doing so. These are going to be some of your most basic methods, and that is the windmill and the water wheel. Water wheel is pretty basic stuff here. Let me see if I can grab one. There we go. Recipe for that is made with a bunch of water wheel segments around a steel ingot. I know. This one here is probably the only thing that's preventing you from making it, but it is better than the windmill. Now, the segments on that, of course, is just a bunch of treated sticks and treated wood planks, which you need 4 of those. And you can have up to 3 of them connected onto a kinetic dynamo. which then collects the power and can transfer it onto your capacitors or other machines that you may need. Now, before you can get to that, because obviously that requires steel, but it's just one piece of steel. So your first few pieces of steel, I recommend putting into water wheels because they can generate quite a bit. They typically, if you've got a setup similar to this, I mean, this is really basic. This is not taking advantage of where all the water is or can go. You could get this up to around 90 RF per tick. Each water wheel generates about 20 to 30 RF per tick, well, it can be a lot less. The more water you have surrounding it in kind of a C shape, the better off you're going to be, and it has to be flowing water as well. Now, in this case, I don't think I have the water flowing quite as I should, but it's just here for example's sake. Here's a helpful tip for you. If you have your kinetic dynamo here, and you currently are trying to hook up your water wheel, you're going to want to hook the water wheel up after your kinetic dynamo is in place. You can always put the water in afterwards as well, but just remember where there's that circle coil of copper is where you want to connect it, and then on the center block out from there. Then you want to have your flowing water blocks going around it. Very simple, very straightforward. And then on top, you'll see this little orange thing. That's where you can add your connectors. Otherwise, you can always remove the face of this thing, but if you do that, it might reset your water wheels, and you'll have to, reattach them again. Now, up here we've got your windmills. Let's start off with the basic windmill. This one here is made with some windmill blades around an iron ingot, which is just some treated sticks and wood planks. Once again, creosote access. And with that, the higher up in the world it is, the windier it is, the stormier it is, the better off you're going to be. It's going to generate more RF per tick. But it's only going to top out somewhere between 4 RF per tick at the very lowest to 50 RF per tick at the highest, depending on if it's at the highest level and it's stormy and thundering and stuff. Now, if you upgrade that to a improved windmill, which is made a little bit differently, you then need a steel ingot with improved windmill blades, which uses a regular windmill blade and some of that tough fabric that you make with the hemp that I mentioned earlier. So this also requires steel, but if you don't want to go steel, you can still get these going here. Now you'll notice that they are connected to kinetic dynamos. Now these here are made with simply some iron, redstone, and a copper coil block, which I think I've showed you before. The copper coil block's just a bunch of LV wire coil around an iron ingot. Now these are for basic power gen. I do recommend that you always go for the better version so that you can get more power, and the water wheels are usually your best bet for that. But sometimes people just want the look because these things look really cool, I have to admit. But you notice the speed of it. You know, that one where it was 4 to 50, this one's going to be double. And it's, it's a little bit more expensive, but hey, that's what happens when you're trying to get more things to work for you. Now, I have some MV coil. I'm not going to use that. I'm going to use LV coil. I can hook this up here to these. Let's hook that up there, and that to that. There we go. Now, you can see 24 flux per tick into this little LV capacitor. And that is just on a regular day, nothing fancy going on. And if I snip this, there we go. And then this gives me about 11 flux per tick. So you can see it's about double, for that. And then of course I've got relays here that aren't doing anything. This doesn't actually have any power coming out of it at the moment. I would have to do this to this. But I can't connect multiple wires to one connector. That's what relays are for. So I would have to disconnect this from that first. There we go. Now I can take this coil to that one, and it should efficiently, power these lights if the output is set. Set it to output, and then it won't power because that, once again, is a relay. So if I choose output on the top, there we go. Lights are powered, which I mentioned these before, but never really covered them. Powered lanterns are very powerful. These require iron plates, 3 of which, redstone, glowstone, and some glass panes. You get 3 of them for that, which is utterly fantastic. The reason for that is because these act as a mob despawner, sort of like a magnum torch if you're familiar with extra utilities, but it will not allow mobs to spawn within 32 blocks of these powered lanterns. So you can surround your town with them and therefore keep your town safe from invasion from mobs. Really wonderful stuff. Plus, it'll give off the same light effect as glowstone, similar to the other lanterns that we showed you before. So I hope you guys enjoyed today's episode of Getting Started in Immersive Engineering. Really just getting into some of the power, how to create it, how to hook it up, and some of the entry-level stuff for it. Join me next episode, where we will be covering a little bit more of item storage, fluid storage, and some of the interesting stuff you can do with that. Don't forget to give a like, subscribe, and share the Mischief with others if you think that they'll enjoy this video series. And until next time, folks, I'll see ya.